Hello, my name is Aitem Amer. I will present to you about the materials that me and my teammates Taufik and Ofik are thinking that can be used in the spacecraft. So have fun. The problem. In this picture, you see the problem that we focused on entering and re-entering to planet atmosphere and what materials can resist the high heat that is created from the friction of the air. Okay, mind map. We are talking about the materials which we can use in the space. We are talk about these favorite types, uh, properties, cost, um, and what you can see we are talk about what solution we are looking for and production of our product. We will focus on the prototypes. We are looking for low density material and high strength and very high heat resistance. As you know, entering the atmosphere requires the materials to be withstand high heat and absorb great efforts. Um Features that are most important to us: strength, lightweight, heat resistance. Now let's look at the types of materials that can be used in the space. You can see aluminum, titanium, tungsten, carbon, and iron. All this material is very special. Now talk about the problem. The problem is high temperature and fatigue when the spacecraft entering to the atmosphere. We think about the solution, and the solution is we need to choose a strong and lightweight material. And we think about the manufacturing process. As you can see, the production process will probably be expensive, but you have to think about the dimension of the product and its production process and whether it's possible to manufacture from these materials a space ship. Um, okay, that's it. Taufik will continue. Um, I'm so happy to present to you this presentation. Thank you.
Hello, my name is Tawfiq. I will talk about the solution. So, Haitham talked about the problem that we give it a solution. Our solution was to replace the material which are used today with improved material with strength and heat resistance properties. Like those materials were are mentioned in this picture. These materials we are think should use in spacecraft in the future. We will talk about each one separately.
One of our materials was a metallic glass, or amorphous metals, are novel engineering alloys, with the atoms occupying more or less random position in the structure. That what make it useful than other materials. And in this picture you can see the properties of metallic glass. And now we will talk about superalloys. This material have a lot of uses, like in machine work in high pressure and temperature conditions. That's why should use it in aerospace industry. Its properties give us the ability for these uses. Margin steel. These materials have a low carbon what give it good weldability. That means we have the ability to use it in a heavy structure or big buildings. In conclusion, the material have a big elastic field. And now my friend Onfik will talk about this material's properties, weak and strong points. Thank you.
Hi guys, my name is Ofek, and I will continue to fix last picture about the margin steel. In this picture we talk about the strong and the weak points of the margin steel. As you can see, the weak point, one of the weak points that we measured, that the margin steel cannot hold a good cutting edge, but but it have a lot of strong points that's good for us in the spacecraft. The margin steel without losing malleability, it have a good weldability, a high hardenability, and a good fine surface finish. About the solution, that we actually think that will be in the future, and what we need to do in the future, that it produce special materials with low density and high strength, because it's the most important thing about the what the spacecraft need to be, about the material, about the structure. It need to be very strong, it need to be light, and of course that not said here that it need to stand in high temperature, because like you said in the start of the presentation, in the entering and re-entering into the atmosphere, there's a lot of refraction that's made a lot of heat, and it's very dangerous when this heat is get inside to the spacecraft and actually melt everything inside. That was so dangerous in the spacecraft today. The spacecraft should be manufactured for mining steel, super alloys, metallic glass, and all other stuff, but this is the material that we specific study about, learn and do a research about. All these materials are very special, and if we take a chance and use these materials, maybe the problem will be solved in the future. In the final picture, as you can see, we show you a model for the spacecraft, that what we think that should be the spacecraft in the future, that's with the new materials, like the margin steel for the wings because of their strengths, super alloys and carbon tubes, again because with this, because of their strengths, and of course the heat resistance, and they can of course hold in a lot of heat, like we said in the earlier pictures. The metallic glass for the windows, again because of the strengths, because they crystallic, not crystallic, morph, that can change. They can change and make that very strong, and very transparent. That again, the pilots can see actually from the space and navigate in the space and back and to the Earth. In conclusion, the spacecraft, not the spacecraft, sorry, the materials are not enough developed, and actually doesn't used for this purpose yet, but they are still in progress, and trying to the research trying to make materials are with more good properties that can make the space program much more cheaper, much more safer, and maybe in the future not long in the future, these materials will be used on the spacecraft, and all these things that we said in the presentation will happen, and it's just matter of time. So we need to keep our eyes and ears open to all the latest technological developments. We don't want to get left behind. So thank you guys. Have a good day.